All right, so here we are with 4.2, law of cosines. All right, now again, law of cosines, a little bit harder to memorize that one, but you won't have to worry about that because you have your formula sheet. But a squared equals b squared plus c squared minus 2bc cosine of a. The one thing that I always sort of use to remember the law of cosines is that whatever side I have here isolated is the angle pair, is the side angle pair with the angle that I'm using in my formula. So if you can remember it that way, that's great. Okay, so we'll talk about a couple examples here as far as when we use law of cosines. Remember, law of sines, the winner there was an angle side pair. So obviously, if we have side, 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 okay, we don't have an angle side pair. So if I draw a triangle ABC here, all right, I have side A is 13, I have side B is 7, I have side C is 19. I do not have an angle side pair here, all right? Therefore, I must use law of cosines, all right? Now, it doesn't really matter which angle I find first, okay? I'm going to make my list. That way I don't leave anything out. I'm going to fill in what my givens are. So side A is 13, side B is 7, side C is 19. I'm going to choose to find angle C first. All right, so that would be this angle right here. So when I set my formula up for angle C, it's going to say 19 squared equals 7 squared plus 13 squared minus 2 times 7 times 13 times the cosine of big angle C. Okay? Now, because I'm looking for an angle, right, this formula probably isn't the best one. I could use it if I really wanted to. However, we do run into some issues with solving that sometimes. So if I reference back up here, okay, they give me an alternate form of each formula, so that way I can find just the angle, okay? And again, when you're trying to memorize these, not that you have to, I memorize this based on the fact that, hey, if I'm looking for angle C, then angle side C is the one that's being subtracted in my formula, okay? So I'm going to go back down here to my problem, and I'm going to rewrite this using the angle formula because I think it's easier, all right? So if I do that, I have the cosine of C, that's my unknown, and that's going to equal a squared. Okay, so 13 squared plus 7 squared minus 19 squared divided by 2 times 13 times 7. All right, and then I'm going to type that into my calculator. I'm going to find out the cosine of angle C is going to equal the fraction negative 143 over 182. All right, remember if I'm finding an angle, I need to do the inverse cosine, okay, of that fraction, and I get my angle for C, which is 141.786 degrees. I'm going to round that to 141.786 degrees, and then for our purposes, I would round that to 142. Okay. And then after that, once I find that first angle, I now have my angle side pair, right? Which is what I wanted. I would go back to law of sines. I wouldn't have to use law of sines. I could continue down the law of cosines path if I wanted to, but it seems as though law of sines is easier to set up. So I'm going to go ahead and set up law of sines. So sine of 142 over 19 is going to equal the sine of b over 7. Okay. Actually, I'm going to find angle A first. Doesn't really matter, I guess. Okay. So if I solve that then for angle B, okay, I would have 7. Remember, I'm cross multiplying this here. Okay, cross multiply. So 7 times the sine of 142. Okay. 142. Divide that by 19, and then I'm doing the inverse sine of that, and I would get 13 degrees for B. So again, if I show you a little bit of work here, it'll be 7 times sine of 142 divided by 19. All right, equals the sine of B. Then I do the inverse sine of that. I wait till the very end to do the inverse sine. I find out that angle B is 13 degrees. 13 degrees, and then I would use triangle angle sum to find the last angle. So 142 and 13 is 155, and that will give me what, 25 degrees for my last angle. Okay, so that will be the complete process. All right. Then second example here would be if I have two sides in the included angle, so side, angle, side. Again, that does not offer me that does not offer me an angle side pair. If I know this angle is 102, but I don't know side A, then law of sines is still no good. So I know that side B is 5, I know that side C is 3. I'm going to still make my organized list, okay, so I don't forget anything. All right, I know that side C is 3. I know that side B is 5. And then the angle A is 102. This would be a situation where I use that original formula for law of cosines with the A as the one that is isolated. So A squared equals B squared plus C squared minus 2B C cosine of angle A. All right. Now, the nice thing about that formula is I can literally type the entire thing at one time. All right. So I would have, let's see here. Plus 3 minus 2 times 5 times 3 times 2. Right. And I would take this. That gives me 40.237. And again, I type that entire thing, I calculate it one time. Then I take the square root of that, which is easy, and I get 6.34. I'll keep 2 decimal places since it's a side length. All right, and I fill that in for side A, 6.34. Again, the nice part is I only have to use law of cosines once. Once I've used law of cosines once, I can use law of sines from there on out, which is typically easier. So I would do the sine of 102 over 6.34 equals the sine of angle B over 5. Again, cross multiply. Okay, so I'd have 5 times the sine of 102 divided by 6.34. All right, do the inverse sign of that fraction, and I'm going to get angle B as 50.43. So angle B is going to be 50. I'm going to round that to the nearest whole number. Okay, which means that angle C using triangle angle sum is going to be 28. All right, so I've solved my triangle completely. All right, when you get into the applications, it's really no different. The biggest part here is drawing the picture and realizing which scenario you have. Do you have side, 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 or do you have side, angle, side, right? So 2 airplanes leave the airport at the same time. Okay, so there's the airport. All right, one plane, well, hold on, I'm going to draw my picture very accurately. One plane flies directly north, okay, 420 miles per hour. Okay, another plane flies with a bearing 75 degrees east of north. All right, 75 degrees east of north. Okay. At 375 miles per hour. Okay. How far apart are the planes after 2 hours? So the tricky part here is that you have to remember that if they flew for 2 hours, I'm not going to use 420 and 375, okay, right? Because that's how many miles per hour they're driving or flying, okay? So I need to then convert that, right? So this would here would be 840, and this one here would be 750. But I notice that my angle stays the same. So I have side, angle, side, okay? And I'm finding the distance between those two planes after 2 hours. Okay, so I would be using the formula, okay, that allows for the side angle side, right? So that's the one that looks like this. So d squared equals 840 squared plus 750 squared minus 2 times 840 times 750 times the cosine of 75. All right, and then dot, dot, dot. I would solve that for d squared. I'm not going to do that for you. I think you can handle that. Last one here is Herons Formula. So this gives us a method to find the area of a triangle when you don't know any angles. Okay, so I know you know how to find the area of a right triangle, right? Area equals 1/2 base times height, okay? And then we talked about how to find area of a non-right triangle, right? 1/2 AB sine C, as long as you know side angle side, right? But what if you don't know any of those three? Then you have to use Herons Formula. All right, so first here we're going to find one part of this here you'll see is this S, okay? So that's part of something we have to find here to be able to do that. And we're not going to prove why Herons Formula works. We're just going to use the formula. So to find that, we take half of the sum of the three sides, okay? So 7 plus 16, okay, plus 18, all right? So essentially you're finding half of the perimeter, okay? So that gives us, in this particular problem, 20.5, all right? And then I use Herons Formula for the area. So now I'm just plugging this in where square root 20.5 times 20.5 minus side A, which is 7, times 20.5 minus side B, which is 16, and then times 20.5, all right, minus side C, which is 18. And it's a formula, so essentially I can plug all of that into my calculator at one time, okay, to figure out what the area of this non-right triangle is, where I only know three sides. So if I do that, I should get 55.798, in this case, meters squared. And then we will provide directions for rounding for you. And then there's one more application down here. 120-foot tower is leaning. 160-foot guy wire has been anchored 82 feet from the base of the tower. How far from the vertical is the tower leaning? Okay, how far from the vertical is the tower leaning? So, let's see here. Try to get this picture correct. All right, so if this tower is leaning, okay, I'm assuming like this, the leaning tower of pizza. So it's 120 feet. Okay, the guy wire, I'm assuming, would be attached here and pull the tower back that way so it doesn't fall. That's 160-foot guy wire. Okay, and it's been anchored 82 feet, all right, from the base of the tower. So this is side, 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 right? So how far from the vertical is the tower leaning? We're looking for the angle, the angle at which the tower is leaning. All right, so again, that will be across from the 160. So that means as I set this up, okay, cosine of C is going to equal 120 squared plus 82 squared minus 160 squared divided by 2 times 120 times 82, right? Plugging all that in. So I would get the cosine of C equal to, I should get the fraction, negative 4476 divided by 19,680, and then I do inverse cosine to find out my angle is 103.5. So how far from the vertical is it leaning, right? 103 wouldn't be the answer, okay, because that means it would be fallen over and now below the horizon, right? Remember, the vertical is 90, okay? So we actually want to know this angle here. So we have to not just solve the problem, but then answer the question, right? So how far past the 90 is it leaning? And that would be 13.15. Oh, 15 degrees, okay? All right, so that's your law of cosine stuff. Submit these notes and then look forward to the practice.